This problem is about solving a quadratic equation by completing the square, as you can see here. So completing the square, we're going to actually try to get a perfect square out of this equation. This thing could have started with the minus 28 on the other side, but it's already been moved to the right side for us. So what we're really going to look for here is we're going to find out if this is a perfect square. I'm going to leave a big blank there to fill in our perfect square. But basically, I want to think about this. I know that the coefficient in front of the x squared is a. It looks like a is 1 for this equation. Looks like b, which is the coefficient in front of the x term, is a minus 12. The key to completing the square is look at b divided by 2, and that would be a minus 6. Minus 12 divided by 2 is minus 6. Then you want to square that because b over 2 quantity squared is what we want to put in right here. Because it's squared, it'll always be even. Minus 6 squared is a 36, so we're going to add 36 here. But we have to be very careful. If we add 36 here, and we've basically just pulled this number out of thin air and thrown it in there so that we can get a perfect square over here, we can't do it unless we do the same thing to the other side. So I didn't do it up here. I probably should. I definitely should. So I add 36 here. I have to add 36 here. Now minus 28 plus 36 is going to give me something there. Looks like it's going to be 8. Okay, and that's a positive 8. And what I have over here, because this is now a perfect square, it is x minus 6 squared. And so x minus 6 squared will give me the x squared minus 12x plus 36. That's a perfect square. So I'm going to rewrite it down here. And what this means now is that I can take the square root of both sides and try to find something simple over here. Okay, now be careful when you take the square root of both sides. When you take the square root, you have to take the square root plus and minus of both sides. Square root of anything squared here is anything. So what's underneath there is x minus 6 squared, so that comes out. And hopefully we can see that plus or minus square root of 8 is actually plus or minus, because this is equal to the square root of 2 times 4, which is the same thing as square root of 2 times square root of 4. I know the square root of 4 is 2, so this 2 comes out, right? That is going to be my 2, and the square root of 2 stays under the radical because that's not going to be simplified, okay? So what I have over here is square root of 2 times the square root of 2. I didn't say that very well. What I have over here is 2 times the square root of 2. Okay, see how that's the square root of 8? All right, if I square this, I get 4. If I square that, I get 2. 4 times 2 is 8. It works, okay? Remember, you can break this up like this. You can break that up like this. Square root of 4 is 2. I just put out in front because that's how it's usually written. The radical of 2, did I say that right? Square root of 4 is 2. 2 comes out front. The radical 2 stays underneath it, and that's how I get this plus or minus root 2 of 2. Now, if I've got x minus 6 equals that, then I just move the 6 over, and I'm going to get, when it comes over, it becomes a plus. So I get 6 plus or minus 2 square root of 2. That's my answer for this polynomial, for this quadratic. Okay, so what I'm going to have is 6 plus 2 square root of 2 and 6 minus 2 square root of 2. Okay, so there's my two solution sets right there. If x equals either of those, that is, in fact, a solution of this quadratic equation.